The cumulative review on Tuesday, the cumulative review test is going to come from 2 cumulative reviews in your geometry workbook. So go back to the geometry workbook, the one that you may have closed, you may have to open it up, and go to your angle section. And under the angle section is a cumulative review, and also under the quadrilateral section is a cumulative review. The angle section, you can go back to your fractions workbook, and that will help you. You can refer back to your notes, and you can refer back to your notes under decimals and exponents to help you with the quadrilateral section. So the first thing I want to review today is greatest common factor and least common multiple with prime factorization. So we're going to start with the numbers 360 and 10,500. So for 360 and 10,500, if I want to find the GCF and LCM of each, first thing I want to do is the prime factorization so that I can look at them in terms of prime numbers. Then you can break this down lots of different ways. I have it written at the bottom, but you would not know that off the top of your head. So I'm going to go ahead and break it down, and I just have it written there so that I can catch any mistakes, make sure I do it right. And so you'll see that for 360, we have 1, 2, 3 2s. We're looking for our prime numbers that make up 360 times 2 3s times 1 5. And that's the prime factorization for 360. Then I'm going to find the prime factorization of 10,500 by breaking that up. 100 times 105, 10 times 10, times 5 times 21, 2 times 5, times 2 times 5, times 7 times 3, and then we have that 5 we don't want to forget about. So when I find my prime numbers here, I have 2 2s, I have 1 3, I have 1 7, and I have 3 5s. So my prime factorization is 2 squared times 3 times 5 cubed times 7. So this is the first piece, is making sure we remember how to do the prime factorization. When you're asked to find the least common multiple, that means you're looking at 2 numbers and you're trying to find the smallest number in their multiplication tables they have in common. So it's the least number they have in common, the smallest number they'll be able to both divide into. Okay? So what I want you to be able to do here is look at the 2 prime factorizations, the prime factorization of 360 and the prime factorization of 10,500, and think about each of the prime numbers as dividing into each other. Okay? So let's start by thinking about the 2 cubed and the 2 squared. 2 cubed is the same as 8. 2 times 2 times 2 is 8. 2 squared is the same as 4. All right, so when we're trying to find the least common multiple, least is smallest. Multiple means in their multiplication tables. So I'm going to look in their multiplication tables. 8 times 1 is 8, 8 times 2 is 16, etc. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, etc. Okay, so I'm looking in their multiplication tables, and I'm trying to find the number they have in common that is the smallest. So obviously, it's going to be 8. So between 2 cubed and 2 squared, 2 cubed would be the least common multiple because 2 squared will divide into 2 cubed, and 2 cubed will divide into itself. So when we're looking for the least common multiple, think through what the words mean. Smallest number they have in common in their multiplication tables. So that means we're looking for the smallest number they both will divide into. Another way I think about it is least common multiple. Least is going to be for multiplication tables. Greatest common factor, greatest are the little numbers. The greatest is where we're looking for the factors, the greatest factor. All right, so when I start putting all this together, the least common multiple is going to be 2 cubed times. Now let's look at our 3's. We have 3 squared, and we have 3 to the first power. 3 just means 3 to the first power. So 3 to the first will go into 3 squared, and 3 squared will go into 3 squared. Now, if I was to think of it the other way around, will 3 squared go into 3 to the first? 3 squared is 9. 9 will not go into 3. Okay? So that won't work. So we have to go with 3 to the first going into 3 squared and 3 squared going into itself. So we're going to end up with 3 squared here. So when we look at our 5s, we have 5 to the first and 5 to the third. 5 to the first will go into 5 to the third, and 5 to the third will go into itself. But we can't do it the other way around because 5 to the third doesn't go into 5 to the first. Okay? So therefore, we're going to keep 5 to the third. And then if we look at both of them, we have a 7 in both of them. Now, what we're trying to do is we're trying to figure out what's the smallest number 360 will go into and 10,500 will go into. Well, in order to do that, we have to have all the prime numbers included from both of these. This is very important. So would we include, since 7 is a factor of one of our numbers, it has to be included. We have to have all the factors of the numbers. So basically what you end up with for least common multiple is you use all the factors and you write each factor down once. So both of these had a 2, we write 2 down once. Both of these had a 3, we write 3 down once. Both of these had a 5, we write 5 down once. And one of these had a 7, so we need to include that as well. So basically we're saying all these factors will go into at least one of those numbers. Okay? And then we choose the highest exponent on each because that's the one that the other factor will go into. For example, the 2 cubed, 2 squared would go into. The 3 squared, 3 would go into. The 5 cubed, 5 would go into. So that's how we know which factor to choose when we have the same factor in both of them. If you will remember, we used Venn diagrams when we were talking about finding least common multiple and greatest common factor. So you can continue using this method as well as the method I just described. So for 360, we can come over to one of these circles and put all of its factors in. So we have, well, first we need to put the ones they have in common in. So they both have a 2 in common, 2 2s in common. They both have a 3 in common. They both have a 5 in common. And so over for 360, I have left another 2, another 3, and that's it. So I have my 2 cubed, my 3 squared, and my 5 for 360. And then for 10,500, I have 2 squared, which is already in my center, the overlap piece. 3 is already in the center. 5 cubed, we have 1 5, so we need 2 more. And then we need our 7. Yep. To find the LCM using the Venn diagram, we multiply all these numbers together. And you'll see them reflected up in the LCM. We have 1 2 3 2s, we have 2 3s, we have 3 5s, and we have a 7. So for the LCM, you actually multiply all these together. It's using the overlap in the middle that gets rid of having to double anything up. So it's the overlap that allows us to get rid of anything from happening twice that we don't need. Okay? Now we're going to use the same diagram for finding the GCF. So, for the GCF, we multiply all the numbers in the middle. So let's talk about the GCF. The GCF is the greatest common factor. So it's where you look at 2 numbers and find the biggest number they have in common amongst their factors. So again, let's take the 2 cubed and the 2 squared from our different numbers here. And 2 cubed is 8 and 2 squared is 4. Well, if we're talking about factors, we're talking about numbers that will go into either one. So like for 8, we have 1 and 8, because 1 times 8 is 8, and 2 and 4. Factors are numbers that go into a number. For 4, we have 1 times 4, and then we have 2 times 2. So our factors are 1, 2, and 4. So we're looking for the greatest common factor. So we're looking for the biggest number they have in common. So what's the greatest common factor of 8 and 4 is the biggest number that will go into both. Therefore, 2 squared is going to be our GCF between 2 squared and 2 to the third. So the way you think about it is that you're asking yourself, what will divide into both of those? Well, 2 cubed will not go into 2 squared, right? It's too big. That's like saying 8 divided into 4. That won't work. But 2 squared will go into 2 cubed, and 2 squared will go into itself. Therefore, 2 squared is our greatest common factor between the two when we're looking at just the factor of 2. So we're going to have 2 squared. Then if we look at the 3's, we have 3 squared and 3. 3 will go into 3 squared, but 3 squared won't go into 3. So 3 goes into 3 squared and 3 goes into itself. So 3 is the greatest common factor between those two, so we write that down. 3 is also 3 to the first. Doesn't matter if we put the 1 there. Then we have the 5 and the 5. Yes, greatest common factor between 5 and 5 cubed is 5 because 5 will go into 5 cubed and 5 will go into itself. So we're going to write that down. Now we get to our 7 at this point, and we're trying to find the greatest common factor of these two numbers, the 360 and 10,500. Well, the thing is, to find the greatest common factor, we have to find a number whose all of their factors, the greatest common factor has to have all of its factors going into both of those numbers. So since 360 does not have a factor of 7, 7 will not go into it. Therefore, 7 is not going to be one of the greatest common factors. Okay, so we don't include our 7. So the GCF is 2 squared times 3 times 5. Now if we look down in our Venn diagram, we can see the same thing. We have 2, 2, so that's our 2 squared. We have 1, 3, and we have a 5. So you can also use your Venn diagram to find your greatest common factor. And then you just multiply those together. So 2 times 2 is 4 times 3 is 12 times 5 is 60. So our greatest common factor is 60. That's the biggest number that will divide into 360 and 10,500. And our least common multiple, when we multiply that out, is 63,000. So that means that for 360 and 10,500, the first number they have in common in their multiplication tables is 63,000. On your homework, I want you to use a calculator when you get to the point where you need to multiply your factors of the LCM. However, on the test, you will not be allowed to use a calculator, but I won't give you anything too long or hard to need a calculator, just some real basic long multiplication, just real basic. Quick review of place value. When you are looking at your place value, you always have 1 tens hundreds, 1 tens hundreds, 1 tens hundreds, with the exception of on the right-hand side of your decimal place, where we have to start straight with our tens. We skip our ones. But there we go, 10 hundreds, and then we go straight into 1 10 hundreds, 1 10 hundreds over and over again. So that's the first pattern you want to recognize. Okay, the next thing you need to know is the patterns of numbers, hundreds, thousands, millions, billions, trillions, in that order. So you need to know that the first 3 are hundreds, although we call them ones, tens, and hundreds. The next ones would be 1,000, 10,000, 100,000. Then 1 million, 10 million, 100 million. Then 1 billion, 10 million, 100 billion. 1 trillion, 10 billion, trillion, 100 trillion. Then on the other side,